this video. All right, so this is uni science undergrad. So this is science like physics, chemistry, mathematics for undergraduate students. Now this one is coming from foundational mathematics under rational functions. Let f of x be equal to 2x plus 3 divided by x minus 1. Determine the domain of f of x. Okay, find the vertical and horizontal asymptotes. Express f of x in the form of a plus b over x minus 1. Hence, determine the range of f of x. So without wasting much of our time, let's dive into the question. We have been given that f of x is 2x plus 3 divided by x minus 1. This one is an improper fraction. Do you know why it's called an improper fraction? Because the degree of the numerator and the degree of the denominator is the same. They are of first degree, so that becomes an improper fraction. And, well, what do we do? How do we find the domain? Now, usually when you are carrying out the domain, for the domain, we focus on the denominator, okay? So you set the denominator equal to 0, then you solve. So you solve, get 1. This means that your value down here should not be 0, and it can only not be 0 when you remove 1. Okay, meaning from the domain, I'm going to exclude x equal to 1. X must not be equal to 1. Okay, meaning my domain, okay, ranges from negative infinity to 1. I'll remove it, union, all the way from 1 to positive infinity. So I'm going to remove everything everything to do with 1 should be taken out in your domain. Meaning, I'm using curved brackets to indicate to say 1 is not part of the solution. That's a domain. How do we find the vertical asymptotes and the horizontal asymptotes? So, what is an asymptote? An asymptote is a line which the curve approaches but does not touch. Let me give you an example. We can have an asymptote, let's say x equal to 2, right here. So maybe another asymptote here, maybe y equal to 2. Then you have a curve like this. So the curve cannot touch this point, cannot also touch this point. Reason being, this one's an asymptote. It's like a no-go area. That's what an asymptote is. The curve will keep on approaching it, but can never touch that line. That is what an asymptote is. So let's look at vertical asymptotes. Vertical asymptotes. Okay, so how do we find the vertical asymptote? So the vertical asymptote occurs when the denominator is 0. So it occurs when the denominator is equal to 0. That's when the vertical asymptote occurs. Okay, so we set the denominator equal, which is 1, equal to 0, and our x equal to 1. Meaning the vertical asymptote is just equal to 1. Easy. So meaning the vertical asymptote, okay, is x equal to 1. That's all. That's all. Then how do we find the horizontal asymptote? All right. For the horizontal asymptote, this is 1, 2. So for the horizontal asymptote, compare, in such a case, just compare the degree of numerator and the degree of the denominator. Okay, look, the horizontal asymptote is usually a y value. Now let's check the degree of the numerator and the degree of the denominator. So let's check. So of them, like I said in the beginning, they are all x to the power 1 and x to the power 1, meaning they have the same degree, right? If they have the same degree, we now take the coefficients. So they have same degrees, right? So the numerator has the same degree as the denominator. So get the coefficient of numerator, divide by the coefficient of denominator. Okay, that's what you do. And if that's the case, then what I'm saying is the coefficient of the degree here, which is degree of 1, the coefficient is 2. And the degree here is 1, but the coefficient is also 1. Meaning y equal to 2 is our asymptote. That's all. Then C, express this in form of this. Now, we just have to divide. That's all. Okay, just a matter of dividing there. So we are going to use, whether it is in, what's this? What's this? We can use partial fractions if you want. Sorry, yes, if you want, we can use just the normal division. And here's the thing. If I use long division, if I use long division, I get 2x plus 3. Divide x here and here, you get 2. 2 times x, you get 2x. Minus 2 times 1, you get 2. Subtract. Here you get 0. 3 minus negative 2, you get 5. Right? This is your remainder. And you're done. Because x can't go into 5. Meaning, 2x plus 3, x minus 1, is the same thing as 2 plus remainder 5 over x minus 1. You've done it. All right, the next part is D. It's talking about the range. The range of what? F of x. Now, usually, well, for the range, we can use part C, okay? We just got that. We just found that y, or let me say the function, we just found that the function has been expressed in this form. So there are different ways. From here, I can just get this value and that becomes my range, meaning I start from there. But I want to do it a different way, which you are going to remember. Okay? Let's find the inverse. You can also find the you use the inverse method. We know that f of x is 3x. It's 3x? No, it is 2 plus 3 over x minus 1. So how do we find the inverse? Introduce y. Okay. Then swap. Where there's y, you put x, and where there's x, you put y. Then cross multiply. When you cross multiply, you get xy minus x. And this is equal to 2y plus 3. You are solving for y, so collect everything to do with y. So xy minus 2y is equal to 3 plus x. Factorize y minus 2 equal to 3 plus x. Divide by x minus 2, divide by x minus 2. So your inverse is 3 plus x over x minus 2. Once you find your inverse, get the denominator. So set x minus 2 equal to 0. So you set the denominator equal to 0. So you say x is equal to 2, right? Now, check. For this one not to be equal to 0, the denominator should not be equal to 0. Because if this part is equal to 0, the entire function becomes undefined. So what do we do from there? We need to remove 2 from the entire range. Okay? We need to remove the 2 from the entire range. If we are going to remove the 2 from the entire range, this makes our range this. So negative infinity, we remove 2, combine with, we remove 2 all the way to positive infinity. So these are the values in the y-axis. So the inverse method is easier and I like it. Sometimes the inverse method becomes complicated for something like powers of 2 and 3. What you can do is that rehearse around, okay? Rehearse around and see how you can find the range. The range is just the output, all right? The exact numbers that you can get when you input a certain numbers. We call them the domain. That's what it is. So subscribe and follow for more. Our YouTube channel is this here, Uni Science Undergrad.